This conference will now be recorded.
Okay. Let me open the. Can you guys see my screen?
Not Sekar.
Okay. One second. Let me unshare and share again. How about now?
No,
Hmm.
no, Shekhar, we are not seeing. Yeah, no, it's clear.
No, right now. Oh, hold on, hold on.
Now we can able to see your screen.
You guys can see my screen right now?
Yes, sir. You can see your screen, sir.
Okay, cool. Thank you. This take more time normally, more than whatever. Okay, and then okay. So let me drop this schema and recreate the schema so that SFTB schemas drop table is dropped and then recreate. Okay. So this example is to just when we do the time travel, right? We can do what do you call the undrop, drop, and all this stuff, right? Those kind of scenarios. I just wanted to show you. Let's hold on one more time. Sorry, sorry. Sorry, guys. It might be a little frustrating for you, I know, but please bear with me. Sorry about that. Hold on 1 second. Almost there. So we are trying to create a table and then drop the table and then undrop the table. But here, what I'm going to show you in this exercise, right? I'm going to create a table and then drop the table, create the same table with a different structure, drop the table and create with another structure, and then recover all this back to the original table. So if you look at this, right, this is the table version 1 that I'm trying to create, and then I'm just creating this table. Okay, and then I'm inserting some data into the table, 3 records. Okay, select star from this particular thing, 1 2 3. Okay, and then so once you have this table, right, show tables history will show you whether if the table has been dropped before or not and all the details. Show tables will show you all the tables. Show tables history will show you all the tables which has history, and if you want to filter, you can filter with the name, something like this one, right? Show tables history, like you can do this. Okay, so this is the one. Select star from show tables history. Where is this? Like it shows the same thing here. And if you look at this, right, and table drop down null. You see table drop down null. I'm going to drop this table now. Show tables history, like, and then see there are 2 records. Maybe this is a different schema. We are talking about this test schema only. See, you will see the table was dropped down so and so time. Okay. So in this schema, I have only one, right? If I don't say like, it shows me all the tables which has history. Okay, and now I'm gonna create one more table. So now the table is dropped, right? I'm gonna create a table version 1, the same name with ID and number. Previously I created ID and description. Now it's only ID. Okay, and I am inserting some data into it. Select star from that particular thing. So when I see this data, and I'm dropping this table as well. So the first time I dropped a table with ID and description. Second time I'm dropping the table with only ID. Okay, and then show tables history. See, you will see 2 of them because the structure of the first one is different, structure of the second one is different. So you have two in the part of history. It shows 2 tables which has different structures, right? And then I'm creating the same table name with now here C1 varchar. Okay, describe table, it shows me C1 varchar. Okay, I see 3 of them now. The third one, the first one, which doesn't have a table being dropped. See, drop down null, drop down so and so, drop down so and so. So what I'm gonna do, right? I'm gonna rename the latest one, version 1 to version 3. Now, if I go and say undrop table, right? If I say select star from, see, I'll get the first. When I created a table for the first time, it was ID and description. Second time, only ID. So when I renamed from version 1 to version 3, and then now when I undrop it, right, what was the previous structure of the table that was dropped got recovered, and this is this one. So I'm gonna name it to version 2. Okay, and then I'm undropping the table again. I got the table, the first one which I created and dropped it 100 electrons. So you can undrop even if your table structure is changed, and you can undrop and do all kinds of stuff. Are you able to follow me, guys?
Yes, Shekhar.
Okay, guys, hold on. Guys, sorry, I have to, sorry, guys. Hello? Okay. Mm, yes. Fine, fine. నేను క్లాస్ మధ్యలో ఉన్నా. That should be okay కదా? లేదు, whatever you are doing is best. Fine. Okay, right. Okay. Bye. Sorry, guys. So coming back, this is what we have seen right now. I think I pretty much covered all the details of time travel. So what is the key
Shekhar,
parameter that, yeah,
Shekhar sir, like we created three tables and we dropped two tables. So third drop would be giving the first table created, right?
mm-hmm. Hmm.
Should we follow the sequence like first we created, dropped, and second we created and we dropped, and again we regained the first structure and data? Is that how it works?
Yeah, normally whenever you undrop, right, whatever the latest structure that is available, the metadata will be um, retrieved. You, if you have created a table with five different structures, same table name with five different structures, and so it goes in the chronological way. If you're undropping from the latest one, right, it keeps on fetching, retrieving the data that is the latest
Older one.
metadata structure. Yeah.
Okay, fine, sir. Got it.
Okay. Yeah. So the next topic that we're going to see right now, I think, now what is the important parameter that we talked about, the time travel? What is the parameter that defines the storage criteria and all this stuff? Do you remember that?
Data retention period in days.
Yeah, data retention time.
Time in days.
Data retention time period in days. That is the key parameter that decides the entire storage of the table. So you have to have that handy or look at the default parameter, and then based on that you can decide. Okay, that's pretty much. And now let's look at the cloning part of it. So what is a micro partition? We talked about micro partitions, right? Yes, do you remember micro partitions? We talked about micro partitions to some extent, and we thought of talking about when we discussed the performance part of it, right? So, in the time travel part, I explained a little bit about micro partitions. Do you remember that? Yes, no? Yes, you have to speak to me, please. The reason is right. I don't know. We are sitting in different parts of the world. I just want to gauge your pulse whether whatever I am talking is getting digested by you or not. If you are
Shikhar sir, if you could explain little, uh, that should be fine, I guess.
okay, so then if that is the case, right? So, like I talked about, I'll explain you one more time. This micro partition is like a small partition that whenever you try to save some data into the table, right? In, for example, you've created a table and you have inserted 1 million records. So this 1 million, I showed you an example how to look at the micro partitions as well, right? If you go to the history part of it, look at the profile, you'll see the
Yes,
total number of micro partitions. Yeah, this
yes,
micro
sir.
partition,
Yes.
yeah, yeah, yeah. So this micro partition is nothing but how the data is stored in Snowflake. So this 1 million rows, for example, are split into small chunks of data, and then for each table you have a file in Snowflake, S3 buckets. There is a file, and then this particular data is split into multiple chunks, and 50 MB to 500 MB uncompressed. Think the compressed data is 16 MB. 16 MB of data is written into one particular portion of the file, and that particular portion will have a header, and it has all the data of the records. For example, if you have five tables, for example, if you think employee table only, so in that particular partition, how the data is written is in a columnar format. you'll have employee number, all the employee numbers. Whenever it chunks out, right? Normally it takes about 100k records, and all the employee numbers of 100k records are written in one particular location. Employee number, employee name, all names, hire dates, all hire dates. So everything is written like this in the micro partition. So normally micro partition, if it's a 16 MB means on an average they might house about 2 million records if you have about 30 to 40 columns. If the number of columns are less, they'll have more records. If the number of columns are more, they'll have less number of records in the micro partition. Are you able to follow me? Yes or no?
Yes, sir. Yes.
Okay. So when you come to this particular micro partition in the cloning part of it, right? So what is cloning? Cloning is nothing but making a copy of your database or schema or a table. Okay. Guys, can you hear me? Hello.
Now we can hear you, sir.
Yeah, I lost you for a while, I think. So I was speaking continuously, not recognizing that I lost you. Anyway, so cloning is nothing but making a copy of your database or a schema or a table. So basically, we can spin off a prod environment, it's a dev environment out of a prod within a couple of minutes. Let's just say create database name, clone, prod environment, prod DB. Plain and simple. The syntax of DDL is also very simple. So you can clone the entire database and then you can make it ready for development purposes as well. So the only beauty of having this cloning is, right, whenever you clone a database or schema or a table, you will not have additional storage charges. Okay. So for example, let's take an example of cloning a database. Sorry, cloning a table. When you clone a table, right, table will have micro partitions. So when you come and look at here, right, this is the first slide. So the micro partitions, whenever you clone the table, for example, if you think that the name of the table is emp and you cloned it as create table emp underscore clone from, so let me show you the index, create table emp clone uh, clone emp, this emp in sfdb dot sf schema, because I am in a different schema right now. I'm in test schema, right? I'm trying to dot emp. Now I have a clone in test schema. The virtual table is in employee schema, sfdb sf schema. Okay, both of them will act independently. You can do inserts, update, deletes on the source. You can do inserts, update, deletes on the clone table, and the data. If you do that, update the emp, the data is not reflected in um, this particular clone table, and if you do insert, update, delete on the um, clone, that is not reflected back on emp. So what happens, right? They just, if you look at the background part of it, behind the curtain part of it, if you look at this particular diagram, right, picture, the micro partitions are shared between the tables, same micro partitions. So whenever you query from EMP clone, it goes and reads the same micro partitions where EMP micro partitions are there. Okay, and if you insert some data, it goes and creates one more partition which is only specific to the clone. For example, you have created some data for clone, it creates a partition, and this is completely a metadata action. The cloning part of it is completely works on metadata action, metadata layer basically. So the all the micro partitions shared between these two tables are stored in the metadata, and whenever you query, for example, you query emp underscore clone, it goes and looks what are the micro partitions that are shared between emp and emp clone. It gets you the data. Now we have inserted 100 records into emp clone. It goes and whenever you query the table, it goes and gets unchanged data from the micro partitions, and then the changed data, the new micro partition that it has created, that particular data, it merges both of them and gets you on the fly. Are you able to follow me, guys? Are you
Shekhar,
able to follow me?
Shekhar,
Mhm,
Keshav here.
mhm.
Yeah. So both the tables should be in the same account, right? Whatever you're saying.
Yeah, that's what I'm going to come. So
Okay.
whenever it should be in the same account, cloning can happen in the same account, it cannot happen between accounts. For example, you have a different url for prod, different url for qa, different url for dev. You cannot clone between accounts. There is another way of cloning, getting data back to replicate the and create the development environment. That is altogether a different route. This one, if you want to in the same account, then you can clone. Are we clear?
Got it, sir. Yeah. Thank you.
Yeah. So for example, think that this is so this is an example of dev and prod. So prod is the one which is active, which has all the micro partitions. When you spin up a dev environment, right, all the micro partitions are shared between dev and prod. And when you go and create some data in dev, right, they create new micro partitions. Can you see this? These three are only relevant to dev. It has nothing to do with prod. And in the same way, if prod does something else, right, you will see some more new micro partitions that are only relevant to prod, not for dev. Okay. I think you guys are shy today. I'm not sure. You're not speaking to me, or it might be very easy. You are understanding everything. You don't want to talk to me. It's not moving up or down. Hold on. So what is cloning? Let's look at the theory part of it. Cloning is also called zero copy clone or zero copy cloning. It means zero. There is no charges, storages, whatever. It's not there. So that is the reason they call it as zero. Copy means you're not really copying anything. You're just sharing things here. Okay. So how does it happen in the background, back end? Because we have this, if you look at from the cloud perspective, don't even think of S3, sorry, Snowflake. In S3 buckets, you have files. You can share the files to somebody else. It's a read only, right? You can see in a Linux box, you have a file and you can give read only access to any other user, right? So that he can also look at the file. The same way, the files in the S3 buckets, which part of a table that are wrapped around, and that they are granted access to a different user so that they are also looking at it. That is the underlying stuff that happens. Okay. So cloning is also referred as zero copy cloning. You can create a copy of database, schema, and a table. So whenever you clone something, right, this at that particular point of time, it gets the entire snapshot of the database or schema or the table data, and then creates another copy of it. And the data is not really duplicated. There is no data duplication here. Only the micropartitions are shared here. Okay. And the cloned object and then the source object both are independent of each other. Okay. You can do DML activity on both, and it won't be reflected on either of the objects. Okay. So whenever you clone a database, right, it clones all the what do you call schemas and tables. When you clone a schema, it clones all the objects underneath the schema. When you clone a table, right, just the table is only cloned. Okay. So whenever you clone an independent object, right, see for example, I have a table called EMP, and then I have given privileges on EMP to 5 different rows. When you explicitly clone an object, then the privileges are not carried forward. You have to go and then explicitly grant on the cloned object to the rows if people wants to get access. So in Snowflake, it's all role driven, not user driven. You cannot grant the privileges directly onto the user. You have to grant it to role, and the role can be assigned to a user. So, but if you clone a schema or a database, then the privileges are automatically carried forward whenever you what do you call it? Whenever you clone a database or schema, all the privileges that are existing in that particular schema or database are carried forward. Okay, are you able to follow me? Guys, if you're not asking me anything, I'm kind of suspecting whether you're not able to follow me or not. Are you guys all good? Guys, are you able to follow me?
Yes, yes, yes.
Yes,
Able
Shekhar.
to follow.
You're following.
Okay. So if you guys are not talking, I'm suspecting that you're not able to understand me. So that is the reason. Anyway, I'm assuming that you guys are following everything and going ahead. Okay. And then, so now let's go and look at, see, whenever you clone a database, right? The entire database, all the schemas will be cloned. And if you clone a schema, all the objects of the schema, only that particular schema will be cloned, but all the objects underneath that schema will be also be cloned. So normally in interviews, right, people ask you, have you used clone? What is cloning? What is the advantages of cloning? And then what things can be cloned, what cannot be cloned. Okay, so we're going to look at all the objects and we'll see which can be cloned or which cannot be cloned. Okay, so if you go back and look at this particular s- stages, right, now we are going to talk about stages. Show stages, sub schema, right, the one, and I'm going to say show stages. So how many stages do we have? What? Internal, external. We have two stages here. Okay. And now I'm going to clone this particular schema. Create or replace schema. Instead of schema name, you write clone and then the target schema name. Clone SF schema. Plain and simple. What is wrong in this? Onyx. Sorry, I did not give the name of the schema, right? SF underscore schema underscore clone. Create a replace object, clone, so target object, sorry, source object from which you are trying to clone. That is what it is. Now I have created, I'm gonna use schema SF. Okay, use schema. Okay, and if I say show stages, right, I see only one stage, and that is external stage. Got it? So internal named stages are not cloned. Internally, if you have created any temporary stages, they are not cloned. Only external stages are cloned. Are we clear? Okay. So if you look at here, right, this is the one. Individual external named stages can be cloned. Internal named stages cannot be cloned. Okay. So what happens to the table stages? We have table stages as well, right? If I go and see, this is now I am in SF schema clone. So how do we, for example, the name of the table is EMP. How do we see the table stage? What is the command for it?
Listed percentage table name.
List at the rate of percentage EMP. Okay, there is nothing here. So table stages are also cloned. If you have any files in the table stages, they will be cloned as well. External stages and table stages will be cloned. Internal stages will not be cloned, and then the user stage will also be not be cloned. User is only specific to a private user, right? They are also not cloned. Are we clear? Okay. And coming to pipes. So what is a pipe? So when we're talking about pipe, is a different chapter altogether. For this cloning purposes, I'll just explain you what a pipe is, and then we'll talk. Okay. So I'll show you an example of the pipe, and then we'll do whatever it is. I'm gonna go back to SF schema. SF schema. Okay. So drop schema, SF schema. Okay, clone is dropped. So now I'm going to create a pipe. So pipe. So let me tell you about what a pipe is. Snow pipe or pipe is something like when you have a continuous feed of data. Every 15 minutes, every 30 minutes, every 1 hour, you're trying to get the data. So snow pipe normally. So how do you load data from a stage, internal stage or external stage into a table? How do you do that? Guys, I have a file in internal stage. I want to load into a table. How do you do that?
using pipe copy command.
Yes, copy into EMP from. This is nothing but a snow pipe. This is a snow pipe. Create or replace pipe. Name of the pipe as copy into EMP. So what it does is, right, this pipe automates the uh, data ingestion into a table. The moment you put the file into a stage, automatically the data gets loaded into a table. That's it. And you can call the pipe from different sources. There are APIs given, what do you call, and then you can call the API from using Python. I'll show you an example when we talk about pipes, right? I'll show you how to call from different sources. So, or you can integrate with your any queues, and the data from you can read from the queue and insert into, call this snow pipe, and then automatically data gets ingested into the stage. From there it gets automatically copied into a table. So your task is to load data into the stage, and from there copying into the table is done automatically. Okay, this is what it's called pipe, and then we'll talk in detail how do we configure and all this stuff. So whenever you're trying to create a pipe, right, so whenever you're copying a table, so you clone the schema. Now you have table emp in source and emp in clone schema. So the where is this particular stage? Will the internal stage be cloned? No. So then you have to come to the clone schema and create an internal stage. Then only this will work. Okay. First part of it. Number two, you have created an external stage pipe. That means if your show stages, right, and this is my external stage, I can point to the snow pipe to external stage as well. Now whenever you add an S3 bucket, right, whenever you refresh, it gets data copied into automatically into the EMP table. Instead of internal stage, here I am copied into external stage. So whenever I clone this particular thing, well, my pipe will be cloned. Let's see first thing. Show pipes. Okay. Now I'm gonna clone. Create or replace schema. SF clone. I'm gonna clone this. Okay. 5 minutes. The entire 5 seconds. The entire thing is done. Then I'm gonna go to SF clone. This is my. I'm changing. Whenever you change in the worksheet, your context sensitive menu will also change. Now if I say show pipes, see I have this pipes also cloned. Okay, so I have one more. Okay, so this is done, and then there are some challenges with this particular thing. Well, for example, if you're trying to create, I'm going to drop this particular schema. Okay, and I have created a snow pipe like this from insert into sfdb dot sf underscore schema dot emp from. So this is the snow pipe that you have created. Where are we now? We are in a public, right? Okay, I am creating a scheme pipe like this. So whenever I go and create a clone, right, I'm cloning the schema again. Okay, it's already dropped. Okay, now create or replace my pipe. Is it done, right? I'm gonna say show pipes. You see this and copy into definition, right? What do you see the definition here? Copy into sfdb.sfschema.emp. So whenever you get new data into the stage, this particular stage, where will the data go and sit? Will it sit in the source table, or will it sit in the clone table? Guys, I'm asking you a question. Whenever some new data is pumped into the stage, that means you copied some files into S3 buckets, and then automatically the data gets copied into the table, because snowpipe, whenever you create a snowpipe, whenever a new file comes, automatically it refreshes and it puts into the copy into command gets executed. And whenever the copy command gets executed, right, where will it write this data? Copy into what we have written here. Which
Original
particular
schema table
original
with
schema,
original schema.
original table. So when you clone pipes, make sure you don't write fully qualified. If I haven't written like this, right, what happens? Where will my data go and get inserted?
Present schema where we are running the
Yeah,
pipes.
target schema, cloned schema. In the cloned schema, it goes and inserts into clone schema. If you have written a fully qualified name, it goes and inserts into the source schema itself. Even though when you are getting new data into the S3 buckets, it still writes into the source. Are we clear? So make sure that you don't write fully qualified names of that particular whenever you're trying to create pipes. Okay. If the target table is fully qualified in the copy statement, in the pipe definition in the form of db name dot schema name and so and so, data gets inserted into something. If the target table is not fully qualified in the pipe definition, then the data is loaded into the target. That means in the cloned database itself. Okay. So if we can clone stages, but internal stages and then user stages are not cloned. We can clone pipes, but pipes should not be fully qualified. It will clone the pipe, but the data will go there apart from that. The next thing is streams. Okay. What is a stream and then what is a task? There are two things. Okay. And then let's go and see. Oh, okay. EMP underscore. And we have another chapter for streams and tasks. Okay, don't worry about that. Is the next chapter we're going to talk about. So emp underscore sets, create a replace stream and table. Okay, so now you have created a stream on a table. So stream is nothing but the change data capture on a table. Whatever, it's like a trigger in regular databases, right? You create a trigger and then you insert the data into your target table whenever there is a DML activity happening on the table, right? Something similar, they have automated the same thing and they have created a stream here. So whenever you do insert, update, delete on employee table, the changes are automatically captured on the stream. And then let's do an example. I'll show you something. Update emp set salary is equal to sal star 1.1 where dptno is equal to 10. How many records got updated? 3 records. Okay, I'll go and query the stream object. So how many records are? You will see 6 records because it will delete the old data and insert the new data, and salary will have the same thing. So this is delete. Old records got deleted, and then it inserted the new records. If you look at it, right, 5,000 inserted 5,500, 2450, 1300, 1430. Can you see that? So this, and you can use this delta and then you can propagate, you can do whatever you want. So this is called a stream. Okay, guys, you are able to understand what a stream is, right? And how do we, if you use this stream and update something, then the stream data will be consumed. I think I have to use this and then update emp set. Now I have to write a merge condition, a little complex. I don't want to get into it right now. So if you use this emp underscore stream in a DML activity using this table, or if you have created a view on top of this table also, it whenever you use this particular table in any insert or update or delete and then commit happens, the data in the stream is gone. So when we talk about streams, I'll explain you how the data stream will be consumed and all this stuff. But for now, think what is a stream. You know what is stream is nothing but the CDC, change data capture of on any table. So let's go back and see what happens. Whenever you clone a stream, now the data is unconsumed here. When you come back and look at here, right? Did we consume the here data anywhere? Guys, are you able to follow me? Are you able to understand me at least?
Shikhar sir, the stream we understood, but thereafter it's little confusing.
In confusion on what?
What happens like after consuming the stream? What do you mean by
No,
consuming the
that is a
stream?
different topic altogether. We are now looking at when you clone a schema, what happens to the object, stream object that is also cloned, whether it can be cloned or not, and if it gets cloned, what are the implications of it? That's what we are trying to see here. So how streams can be used and all this stuff, that is a different topic altogether. It's completely different session. We have to talk in detail about that. You'll be working day in day out on streams. So for now, just think that there is a stream, means you created a stream. I showed you change data capture. Okay, and how do you consume the stream? If you use this stream, for example, I'll okay, I'll create a EMP target table. Create like EMP. Now I'm using this EMP stream and inserting into the target final table. Insert into EMP underscore final. I'll select emps, and I don't want any deleted records. I just want to the new records. I'll say metadata action is equal to insert. Yes, are you able to follow me when I queried the stream, right? Apart from all the tables that are part of your table, all the columns that are part of your table, it will have extra columns. Metadata file name, metadata is update or is update true or false. Okay. So whenever you do update, so it shows you that this particular thing is part of an update. This insert is part of an update. And when you do it only insert, then this will be false. This update will be false. I don't want to mess you with all the things. I don't want you to get confused. My only thought process for you to understanding is right. You can create a stream on a table. It does all the change change data capture management. The moment you insert some data into your table, it will be reflected in stream. If you update the base table, it will be reflected in the stream. If you delete something, it will be reflected in the stream. Okay. And then now I'm using the stream, I'm consuming, so I'm inserting data into another table. Insert into emp5 does not match because the columns here and columns there are different, right? Empno comma ename comma job job commission the eptno empno ename spelling mistake commission department. Oh, see, three records inserted. If I go and query the employee stream, right, there is no data in the stream. The moment you consume from the stream, the data is gone. And if you do another insert, update, delete, fresh again, you'll see the data here. Okay, I'm gonna do one more update again and see same update. And if I go and come here, I have the data here. So now let's go and clone. Did I consume the data from the stream now yet? Did I consume the data yet? No, right? The data is still there in the stream itself. Consume means if I use the stream and do an insert, update, delete, that is what the consumption is. I haven't done that. The data is intact in the stream. Okay. I am now cloning the schema. Schema is cloned. And if I go on, so select star from EMPS, right? This is the stream. Let's change my schema name. Use schema sfx clone. So what is select star from emp underscore yes does not exist or not authorized. It should work normally. Sf schema Did we drop this? Right? Yes. Is the schema name? I did not drop the. Oh my god. I created one more stream. There was some mess up happened, guys. I don't remember. I am updated it. It has all the 6 records. Now I'm gonna drop the schema first. I'm gonna create the schema again. I'm using the SF schema now, SF clone. Okay. Okay. Do you see here the data that is there in the stream? Unconsumed data will not be cloned. If you change this particular schema to SF schema, right, and you query this, you will have some data here. But when he cloned it, the unconsumed data, it cloned the stream, but it did not get the data that is part of the stream. Are you able to follow me, guys? Yes, are you able to follow me?
So structure and everything is cloned, but the existing data cannot be captured, right?
No, the existing data that is part of the stream will not be cloned.
Yeah, sure. Okay.
Okay, are we good so far? I'm gonna ask you one more interview question. Okay, how do we load data, fixed width data into a table? I have a file. 1 to 10 should go into employee number. 11 to 25 should go into name. So fixed with characters from 1 to 10, 10 to 25, 26 to 35. So this is how it is. I want to load this data into a table. How can I do that? Fixed width data. This is a normal phenomenon in all the databases.
Generally, we do substring operations lengthwise. Uh,
Hmm.
that was my
So how?
initial question, sir, whether you remember it or not.
Okay. Oh, sorry. I what did I answer at the time?
I will say
Okay.
later.
Yes. So how do you handle this data? Yeah. Okay. I have a file. And how do you load the data so that the data gets loaded into the table? Guys, you have to talk to me. Or do you don't want
Lengthwise,
to
we
answer
can. Lengthwise, we
lengthwise?
could do, sir. Yeah, like so doing substring from. Sorry,
You tell me how.
by
Yes.
reading the length.
Okay, fine. By reading that, how do you do that? Tell me the process. Tell me the steps.
So first we will put the file into. Otherwise, we can employ the shell script to split the data, then employ the uh, commas into it. Then we can read from
I
put the file.
I that is a very long process. I don't want to go that route. Then you have to write the entire shell script based on adding commas to it. The shell script programming has to be done. No, I don't want to go that route.
Okay.
So you load the file into a stage, and in the stage you write substring 1 to 10, 10 to, and then copy into table from brackets the entire substring SQL. That's how you load the fixed width data. Okay.
Okay. Got it.
I just want to. You guys are very slow, or I don't know. You guys are not even
You were telling that one
talking.
column we
Are you able
loaded.
to follow me? So
So can you hear me?
yeah,
You were telling you have to load as
one
one
column.
column in stage. On stage, from stage we divide that into section, right?
No, I'm not able to hear you. Can you hear me now
Shekhar sir,
properly?
Shekhar sir, but without format, how are we? Okay, to put the file into stage, we don't need format at all. I
No
got
need.
you.
One row as you want to load it into a table. Sorry.
You're cutting off, Shekhar. You're cutting off.
Guys, can you hear me properly, or are you able to hear Pradeep answer properly or question properly?
The delimited fixed width file, we load that as one single column in stage. From stage, we divide that into substring.
Are you able to hear me properly, please?
Yes, sir.
Yeah, that's true. Okay, we can load it into a stage. From there, you can write transformation query, select substring of so and so, and then use the copy command to load the data. Okay, that's what can be done. And coming to tasks, right? Now we have seen that cloning seems the unconsumed data is not cloned. Only the structure of the scheme is cloned. Okay, and task is nothing but is a scheduler. Like within every 60 minutes, you run this. You can create a task, create or replace task, and then you give the schedule every 60 minutes, and then it runs that particular thing. Okay, whenever you clone the schema, the tasks are also cloned, but they will be stopped. The jobs that are running in your source schema, they will be running, but when you clone it, right, the task will be suspended. You have to resume it. You have to resume the task. That's it. So that the schedule will also start. The moment you clone, task is nothing but a scheduler. You can tell them at every whatever the frequency you want to run a sequence statement or update statement or DML activity or calling a procedure. So task can take only one single statement. Either it can be single SQL statement or merge statement or update statement or insert statement, or any one single SQL statement can be executed through tasks, or you can execute a procedure as well. And in the procedure you can write whatever you want. You can insert, update, delete, do all the things. So whenever a task is cloned, right, what happens? It clones the task, but it after cloning it makes the task disabled. So you have to go and manually resume it. It will be passed in the past state. Alter task resume is a command you have to give, so that it will start running in your cloned schema or database, so that it start running whatever the code that is part of the task. It starts. Whenever you clone it, it gets disabled. You have to enable it. Okay.
Shekhar sir, cloned object will be enabled or original object will be suspended? Haha. Which one is
No, no,
suspended?
the clone task object.
Okay, okay, not the original one, right?
You don't have to do anything. The original keeps on running, right? We are making a
Okay,
copy from the original, right? Only the target cloned object, clone task object will be suspended. You have to resume it.
okay.
Okay. And whenever you are trying to clone, right, make sure you are not creating any tables at the time of cloning. You're not dropping any tables, updating any tables, renaming especially, renaming is tables. Okay. And basically renaming of objects. So whenever you're trying to clone, right, in between, if you're doing some activity, it becomes a mess, right? You know that. Especially rename. Well, the reason for renaming is, right, when you rename, you cannot go back and then do the time travel. We have some challenges with the renaming part of it, because once you copied at the time of renaming, if the rename happened, then the in the cloned schema, it doesn't know what is the proper it loses the link between the table name, and then it becomes difficult for it to retrieve if you want to do time travel and all this stuff. Even on the Snowflake clone database, you can do time travel. Reason, we're still using the same micro partitions, right? Everything the same metadata. I can still do the time travel. Whatever the time travel that is available on the source, that time travel you can also do in the clone schema or clone database or clone table as well. Okay. So whenever you are trying to do a DML activity, insert, update, delete at the time of cloning, and which has data retention period is equal to 0, the objects at the table which has data retention, this will fail. Okay. That means when you are trying to clone and the setting of that particular table is data retention period is equal to 0, and you are deleting some data from that particular table, and when you cloned it, right, you cannot do time travel because it has time travel 0. Time travel is disabled, so you cannot retrieve the data. That's what it means. So normally don't do any DDL or DML activity at the time of cloning, because whenever you're trying to make a copy and parallelly if you're working on the same data set, right, it becomes difficult, right? So at what particular point of time actually the clone happens, it's kind of messy. Okay.
Shekhar sir, one small exercise, request you to do one exercise on cloning the table, one existing table, and dropping it and effect on the clone table.
I am gonna do that. I have an exercise, don't worry, we are gonna do that.
Okay.
So DML activity that I have already spoken. Okay, and then yeah, cloning of historical objects. So in the time travel, when you have seen that, right, you can clone the snapshot of a table at a particular point of time. So how do we do time travel? Select star from that particular table. We can use at timestamp, at offset, and before or after the particular query ID, right? I've shown you the sequels part of it. Do you guys remember that?
Yes, sir. Yes.
Okay. Same way, when you can clone instead of making a copy of the table is storage again, you have to pay for it. Cloning, you don't need to make the storage, there is no additional storage. Create or replace table, table name, clone, at that particular point of time. I've shown you some examples. If you go and look at my slide deck, right, for the time travel, you'll see clone also. You can clone a particular table at a particular point of time. So that means you don't need to have additional storage on the table. Okay, you can clone that. So whenever we see the cloning of historical, okay, one second. Okay, when you go and query this table storage matrix view, this is a metadata view. Select star from. This is from the information schema. Information schema. SCHEMA. Okay, so uh, so when you look at this, this is a Snowflake database which has the account admin. Only account admins have access to Snowflake database, and this is the information schema. So there are two information schemas. Every database will have an information schema. Okay, normally whenever you say table storage matrix, this is for the entire account. If I want to look at the data of the entire account, right, we have to go to the Snowflake account. So we have a Snowflake database. See, Snowflake database. These are the shared database, and then you have an account. So information schema, and then you can go and query the view. So this has all the details. So here, if you look at it, right, you have the table names and the schema names as well. Okay, so I'll do an exercise on this one, and we'll come back and see how do you differentiate whether it's a clone table or a source table and all this stuff. Okay, hold on one second. Okay, so now I'm creating a table called EMP source. Okay, this is in SF schema only. Guys, can you hear me?
Yes,
Guys,
sir.
can you hear
Yes,
me?
we can hear.
Okay,
We
right.
can hear.
I'm creating a table EMP underscore source, and then I'm inserting some data into EMP source. Select star from EMP source. I see these records 100, 200, 300, 400. Source has 100, 200, 300, 400. Okay, and then I'm creating a source clone out of the source, EMP source clone. Okay, uh, select star from EMP source clone. I have 100, 200, 300, 400. Okay, now I'm inserting into EMP source clone table 500. Select star from clone. I see 400 and 500. Okay, and if I go and see EMP source, will I have this 500 record or not?
No, it won't be.
Yeah. See, I have only because whenever you clone it, both of them act independently. Okay. EMP source clone. If I go and look at it, right? This is query reuse. This is what is this particular source clone? It has only one partition, so we couldn't figure out and see that. Okay. Now coming back, if I say clone minus source, I'll see that 500 record. Okay, this is a new record that is added into the clone table. So now I'm inserting into source, not in the clone. 600 into source. If I say source minus this one, right? What will see? I'll see 600. So both of them are different. Okay, and I'm deleting the table, deleting a record from the EMP source 100. So if 100 is deleted from the source, this 100 is still here, but from the source it's deleted. If you query 100, 100 won't be there. So both of them act very independently. Both of them are each different tables. That's what it acts like. But the data set is same in the common. Common data set is fetched. Only the modified data set is fetched from the new partitions. Okay, that's pretty much about this. And then I can clone a database. SFDB clone SFDB. So SFDB clone drop database. I'm still in SFDB only. Drop database demo DB clone. I think I did not create this. This is something else. Don't worry. So this is not part of it. So you can clone a database. You can clone a schema. How do you clone a schema? Uh, and what happens if you look at here, right? Mines. Okay. Remove SFDB, SF schema, and drop table emp underscore source. I'm dropping the entire table now. When I drop the entire table, what happens to the clone table? Any guess? Will the clone table will be there or will be dropped? Will it be there or will it be gone?
It was there, sir, when I tested this one.
Even the source table from which you have cloned is dropped. The clone table still exists. Okay, because the partitions that are part of it are shared, right? So the table that utilizes this entire data set will be there. The partitions won't be gone. the partitions that unchanged partitions plus the partitions that are part of this particular cloned table will be there. There might be some data it's only pertaining to EMP source. After the cloning is done, you would have updated some records, deleted some records. That will be gone. That extra partition that got created, that will be gone. But the common partitions, which the data was not changed, plus the that will be there, and it will continue to reside, and you will have the charges for this particular table as well. Previously, you used to have the storage charges for EMP source, and when you created a clone, you won't have any charges for the clone table. Now EMP source is done, but the EMP clone you are using the same. If you have a huge, for example, if you take EMP source of 10 million records or 100 million records, and then you created a clone and you dropped the table. So when you cloned it, right, you won't have any charges for the clone table. The same charge, the same storage will be there. And when you drop the source also, the same storage will be there. The reason is you are using that storage for the cloned table, right? So you have to pay the same storage charges. Are you able to follow me? Is it too complex, very difficult to understand? What do you think, guys? So if I don't get an answer, I think you are very, very comfortable, and then I'm going to proceed further. Okay. So now this, when you go and look at this particular table, right? Yeah.
One clarification, sir.
Mm.
At the moment, when we have a source table and we create a copy of that, I mean clone of that table A is the source. We created table B as a cloned object and
Hmm.
deleted the table A, which is the original table.
Dropped or deleted?
Sure.
Drop, sorry,
Okay.
drop.
Mm.
So
Sir, are
then
you talking?
cloned object will be there, and from then it will be starting the storage charges, right?
Now, storage charges previously will be there because you were using the source. Source for source you were paying the storage. Now you will be paying the storage for target. There won't be any changes in the, unless until the source has separate data delta that is not part of the clone, then that will be gone. Let me explain you here, right? So emp underscore source, I have 100 partitions. Okay, cloned emp source to emp source clone, 100 partitions shared for the cloned object. Okay, now
Okay.
inserted 100k records into emp underscore source. Now 10 partitions for emp source. Okay, for emp clone how many will have?
100 partitions.
100 partitions. And now you dropped emp source. So 10 partitions will be gone, which are private to emp source table. Okay, now
Okay.
you will have So these 10 partitions which are part of this particular thing will be gone. You still have 100 partitions for the EMP source clone. So your charges will be 100. Storage charges for the 100 partitions. Are you able to follow me?
Sir, but we have dropped the entire table only. No, why it would be having the charges?
When you drop the entire table, whenever you query the clone table, how do you get the data? It it doesn't delete the partitions. It keeps the partitions for the cloned object.
Okay, 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 okay. Got it.
Unchanged data partitions will be there. Only changed data, that means new partitions that are created which are part of the source or which are part of the that will be deleted. That is the reason I told you 10 partitions will be deleted. These 10 partitions are 100k records. When you insert it, it will have 100 plus 10,
Okay,
100 plus 10, right?
okay, sir. Got it.
Yes. Chanakeshwari, you are asking me something. Chanakeshwari, can you hear me? Okay, that's fine. Coming back, right? So now select star from I think table storage matrix. This is the table that gives you the exact storage matrix, how much is the data and all this stuff. Table storage. What is wrong with this?
At the end, it is there is a dot, sir. There should be a semicolon.
Where? In the last, right? Okay. Where table underscore name is equal to, I'll say emp underscore source. I'll say like. And we have to, right? We'll just look for schema is table catalog is sfdb only. So this is the emp source table and the emp source clone. And if you look at the clone group is the one that tells you where is it pointing to. If you look at this, right, 10345, and the id of the source is 10345, the clone group id is 10345. So this particular table is being pointed to this particular table. Can you correlate this? What I'm trying to explain you, it is pointing to this particular id. Even though this particular table is done, this is how metadata internally it tells you whether, if you go and say if id and clone group id is not equal or not same, then that is a cloned object. Okay, where id not equal to clone group id. See, I have test, which is a clone. So I'm getting all the SFDB clone, and then so there are a lot of other things. I have cloned a schema, I cloned a database, so you'll have a lot of things, messy things. But look at here, if you want to understand a simple example, right? What is the clone group ID of this particular table? What is this column? If you look at right, the clone group ID and ID are the same 10345 10345. For the clone table, what is the clone group ID? It points to the original source 10345. Okay, or you can where you can write like this, where clone group ID is equal to ID. This is not the way I have to write it. So I have to join the same table again and then do some things. But you understood, right? It points to the source here 10345, the original ID that is referring to. So it clone group ID is nothing but the original source ID. Original source ID is 10345 for this source table. Okay. So when a table is cloned, it's assigned a new ID and the clone group ID for the original table. Okay. Micro partitions in both the tables are fully shared. The storage associated with these micro partitions are owned by the oldest table in the clone group, and the clone references this micro. Unless until the oldest table is dropped, then it's all referred by the owned by the source. If the source is dropped, then these micro partitions are owned by the cloned table. Okay. And you can look at the table storage matrix view, and you won't have any storage bytes. Only if you have new partition that are created, you will have the bytes that you can see here. Time travel bytes, owned, active, and time travel bytes in the column. How far you can do time travel, and all this stuff is mentioned here. Okay. So if the object does not exist, right, you cannot clone. First thing. Okay. Table IDs I have discussed. Cloning DDL, create or replace, I have shown you, right? Database, schema, table, clone, object name. That's it. Create or replace table, clone, object name, table name. Create or replace database, clone, database name. Create or replace schema, clone, database dot schema name. Period. And we have seen cloning the time travel. Create table my January, clone my source table before this timestamp is an example. Okay. Are we good, guys? I think I have pretty much covered about the cloning part of it. Okay. And tomorrow morning we'll see a new topic. I'll share the slide decks as well. We'll catch up tomorrow. Any questions for me, please?
Shikhar sir, have one question. It's
Hmm?
not related to this, but
Okay,
sort of
go ahead. Hmm?
migration. So, for example, I have migration. I have to migrate a Hive table from which has terabytes of data. What would be the precautions or procedure to be followed? Like how in short, what can be followed?
What is the file format of the Hive table?
It's pipe delimited
Is your Hive on the EMR or is it on on-prem?
on-prem.
Then you have to generate a CSV file with a pipe delimiter. And
Okay.
what is the total size of that particular table?
Actually, we have around 20 years of data, sir. That's very huge table. But what we are actually there are these are the batch. We load the data in with respect to the batch. There is no relation between one batch to another. So we are thinking around
How, how many batches do you have them?
in week one batches we will be having for at least 1 month or uh, three 1 quarter data we are planning
Okay.
to
Then
migrate.
means that means your batch ID is unique, right?
Yes, correct. Yes.
If that is the case, see how much data that you have in batch per day. What is an average data size?
Approximately 20,000 sir, approximately.
20,000 records.
Yes.
And then how many batches you need for a 20 million? Sorry, 2 million.
2 million
2 million divided by 20,000. I don't have a calculator. You let me know how many batches you will
approximately
get.
100 batches approximately.
100 batches, right? You take 100 batches and compress the file.
Okay. Okay.
And then, so, and you can do 1500 and compress the file. So, first thing is 100 batches into one file. You can generate the file with 100 batches, right? You sort the data, min and max. If you think that the min batch is 100 and the max batch is so 100 plus 1000 batches, 1100 should be your max. Select star from Hive table where min id equal to 100 and max id or batch id between 100 and 1010 will give you
Yeah, that point I got
1000.
it, sir. Yeah,
Yeah,
yeah, I got it.
and you
Yeah.
the same way you have to break it down and parallelly generate as now for you, right? 16 MB won't be sufficient. I think make at least instead of 1000 batches, make at least if you have 10,000 batches means how many you'll have 20,000 into 10,000, right?
Yes, sir. Yes.
I don't have a 1 second, 1 second. I'm calculating 1 second, guys.
Sure.
So I would prefer you to go to 600 batches or 500 batches. 500 should be optimal number. Take first 500 batches, generate a file. Next 500 batches, generate a file. And this batch generation of pipe delimited files can be done parallelly as well. You don't need to have. So you have to generate sequels like 500 batches, 1 to 500, 500 1 to 1000, 1000 1 to 1500. So you have to break it down. Each 500 should make a batch, and that comes to 60 to 80 MB of file. And then all these files you can load it in parallel.
Okay. So generally, we will have to break down the number of rows into chunks of files. Then we will have to
Mhm.
either pipe or some utility. We will
Yeah,
have to
yeah.
load.
Yes, you have to compress that particular file and then load.
Okay. Okay. Okay, sir.
Okay.
So, and any like data type precautions that what can be taken care of? Any data type precautions?
I think the best thing, right? You get one batch, load it into Snowflake, and see if you have any challenges. Some sample data, 100K, not even
Okay.
some 1,000 records, and then everything should be fine.
Okay. So
Data
based
types,
on
most of
the
them match.
errors
Yeah,
and based on the
yeah,
errors, we
mm,
can manage the load, big load.
yes,
Okay.
yes,
Okay.
yes. Okay,
Sure, sir. Thank you. Yeah.
no problem. Okay, guys, we'll catch up tomorrow morning. Okay,
Yeah. Thank you, sir.
thank you.